Welcome to Chapter 4. In this chapter we're going to talk about different types of data and how we can interpret it and analyze it. So first let's look at different types of organization for data. To begin with, let's talk about what a random variable is. A random variable is a quantity that can have a value recorded for it or a quality attributed to it. There are two types of random variables we're going to discuss. The first one is a categorical variable, which describes a particular quality or characteristic. So this could be the color of something, the texture of material, could be how someone is feeling on a given day. In comparison, we have quantitative variables which have a numerical value. This could be your age, your score on a quiz, or your height. Alright, let's look at some variables and determine if they're categorical or quantitative. So again, do they have a category or do they have an actual number assigned to them? So for our first example, we have the score you got out of 30 on a test. So again, the question is it numerical or categorical? Since the score is a numeric value, it is definitely going to be quantitative. When we look at your gender, does your gender have a number assigned to it or is there a classification? In this case, you classify yourself as a certain gender, so that is definitely categorical. The weight of a newborn baby is definitely going to be quantitative because the weight has a numerical value. And then the method of getting to school, again, this is categorical because you could ride your bike, walk, get a ride. There's all different descriptions, which would be a categorical type variable. Now we have a different comparison for discrete and continuous variables. Discrete and continuous are both different types of quantitative variables, which means they both have a number assigned to them. A discrete variable is something that has a whole number, whereas continuous could take on a variety of values between given endpoints. So let's look at some examples and determine if they're discrete or continuous. Alright, so we have the weight of a newborn baby. This is a continuous quantitative variable because the weight could be a various amount of weights, and basically there's an infinite amount. We could have 5 pounds, 5.1 pound, 5.2 pounds, and so on. So there really is no definite weight of a newborn baby. The score you got out of 30 on a test. This is discrete because generally you're going to get a whole number. You're going to get 10, 20, 25, or even 30 on the test. You're not going to get 20.1, 20.2, 20.3 points unless there's a very weird scale. So generally, this is a discrete variable. The number of people in a household, this is again going to be discrete because you have a whole amount of people, right? You have 2 people, 3 people, 5 people. Generally, you're not going to have 3.5 people because you can't have half a person. And last but not least, our height. Height is again going to be a continuous variable because your height could be a variety of varied measurements. You could be 5 feet, 5 foot 1 inch, 5 foot 2 inches, 5 foot 3 inches, and so on. And so we have a lot of different heights you could be in. In fact, height is never an exact value because you could have 5 feet, 1 inch, and then some centimeters if we want to keep going. Alright, now that we know the type of variables we have, let's look at some different ways to represent them. So here we have a dot plot. Generally, a dot plot would be something that would be used for a discrete quantitative variable because we have numerical values here. When you're looking at your dot plot, the height of each column is going to represent how many things there are for that value. So in this case, there are 2 different things that have a value of 3. There are 2, 4, 6, 8, 9 things that have a value of 4, and so on. Like if you look over here at 7, there's only 1 thing. So the number of dots are going to represent how many things there are that have that value. For a stem and leaf plot, usually we need a key to interpret this, but the stem part is going to be the ones, tens, or hundreds for the number, whereas the leaf is whatever else we have left over. So when we interpret this, our first number here is going to be the number 9. Our second number is the number 17, and then we have 11, 28, 23, 26, 27, and so on. Usually for stem and leaf plots they are numerical order, but we can see for this one it's not. And this is again usually something we'd use for a discrete quantitative variable. For frequency tables, sometimes we see the tally in the middle, sometimes we don't. Again, the frequency is going to represent how many of the quantity we have. So in this case, we have 2 3s, we have 9 4s, 13 5s, and so on. Again, the tally is not always there. Sometimes it is, sometimes it isn't. And this can be used for a discrete or a continuous type of variable. Once you graph your data, a different way to kind of look at it is it skewed one way or another? So we have three different ways we can interpret it. Symmetrical is generally we have this nice bell-shaped curve, and if you drew a line down the middle, we have the same amount on both sides of that line. If we have something that is positively skewed, that means that we can see the tail end is towards the positive side. So most of the data is over here, but there's something over here, maybe an outlier, maybe just some other variable that's kind of distanced from it, the most of the values, and that would be on the far side, the far right side. Whereas for a negatively skewed thing, we see that again, the cluster is here on the right side, but the tail is on the left side. So the tail for your data is going to kind of show you if it's positively skewed or negatively skewed. Alright, so here's a question here. How many pets do you have? So to begin with, we're going to go ahead and label our axis. Let's say that we have the possibility of having anywhere between 0 and, I don't know, maybe 5 pets. So 1, 2, 3, 4, 5, and maybe somebody has like 9 pets. Alright, now we're going to put a dot for each person who has a certain amount of pets. So let's say that we have 3 people that have 0 pets. And then we have 4 people that have 1 pet. Maybe we have something like 7 people that have 2 pets. And then we have 2 people with 3, 2 people with 4, 1 person with 5, and then we have 1 person with 9 pets. So if you look at the general shape of this, again, we're trying to see if it's skewed or not. We can kind of draw a curve. And we see that our tail is way over here on the right side. So this is definitely a positively skewed graph because of this 9 here. If we wanted to go ahead and take this dot plot and turn it into a bar graph, we could connect things. So we could have bar here, and we see we still have the general shape with a positively skewed function because of that 9. Right? That person's kind of an outlier. They're not really centered with the rest of the data. They're out there on their own, and we can see the tail is pulled that way because of that last person. In this example, we can see that we have a frequency table that's been turned into a histogram, and we can see that the height of each histogram represents how many people there were for that category. So if we look at this, we can see that there were 2 people that had 0 charge cards or credit cards, which means that for our column here at 0, it should go up to a height of 2. So again, the height of a histogram represents how many people there were for that category. If you look at the next one, there were 4 people that had 1 credit card, and our height for that column is again going to be 4. We have 2 people with 5 credit cards, so again here at 5, we're going to see the height of 2. And since nobody had 6 credit cards, there isn't anything there. So again, when we have a frequency table and we're trying to turn it into a histogram, the height of the category or your frequency is going to represent the height for each column, and then for axis down here, it's going to be whatever the category is that we're talking about. Alright, for our last example here, we're going to do a stem and leaf plot for what is your height. So we can have people that have a height of 4 feet, 5 feet, 6 feet, 7 feet, and then so many inches. So the foot part, that's going to be your stem. The inches is now the leaf. So you could be 4'4", or you could be 4'5". Oops. You could be 4'6", 4'7", and so on. Maybe you have a couple people that are 5'2". One person that's 5'3", 6'1", 6'2", 6'4", and maybe somebody is 7 foot exactly, and also 7'1". If I wanted to take these and make a histogram, what I would need to show then is I'd have to have a column for 4'4", a column for 4'5", 4'6", 4'7", and then the frequency that happens on the stem part would tell me how high it would be. So at 4'4", I would have the bar going up to a unit of 1. 4'5" would be 1. 4'6" would now be 3 because I have 3 people that are 4'6". Same thing with 5'2". Again, there are 3 people that are 5'2". So the amount of numbers that repeat here represent how many people or how high a column would be for that example. Alright, that's it for notes. Go ahead and try and do the homework now, classifying things as quantitative, categorical, discrete, continuous, and then also looking at data and answering questions based off of different representations of it. Have fun!